This is Gustav Hallegraaf from the University of Tasmania, addressing the status of global harmful algal blooms with a focus on Australia and New Zealand, designated as OBIS Region 5. I worked with two master students from the European University in Europe, in Brest, Laura Schweibold and Nora Jeffresick, two senior scientists at the Colson Institute in New Zealand, Leslie Rhodes and Lincoln McKenzie, and Barbara Hay, an expert consultant working for the New Zealand seafood industry, and Hazel Farrell working for the New South Wales Food Authority. So some examples of HABs in our region would be HABs with impacts on tourism, like Noctilucus scintillans, causing the closure of Sydney beaches. Impacts on drinking water, for example, from a range of cyanobacteria, and Australia has the oldest official publication on toxic cyanobacteria dating back to 1878, where a bloom of Nodularius pumigena in the brackish Lake Alexandrina in South Australia led to cattle deaths. More recent problems are caused primarily by freshwater cyanobacteria, Raphidiopsis and Anabina dolichospermum, leading to human poisonings in Aboriginal communities, but also here an incident where 1,000 kilometers of the Darling River was contaminated and emergency drinking water supplies had to be brought in. The freshwater cyanobacteria have been excluded from our analysis, at least for this particular purpose. Impacts on fish farms. This is a very big one in South Australia, 1996, a bloom of Chatanella marina, killing 45 million Australian dollars worth of aquaculture tuna. And then the most common phenomena are a range of species that produce toxins. This impacts on shellfish, lobster, abalone, and so on. The biggest event in our region undoubtedly was New Zealand, 1993, a bloom of a species similar to Corinia mikimotoi, leading to a neurotoxic shellfish poisoning event with 180 humans impacted. But the real impact was a closure of the New Zealand seafood industry, and that led to export losses of $2 million, New Zealand dollars per week. As of today, the total number of HAB events registered for this region is comparatively small, 112 events distributed as that. That low number compared to a lot of overseas regions relates to the fact that routine monitoring results from shellfish farms, but also more particularly the finfish farm industry, are not routinely available to the public and are not entered into the system. We have conducted an analysis, but this is done without revealing the precise localities of the industry. And in OBIS records, we have some 68 species reported, 56 for Australia, 64 for New Zealand. Here's some maps that have been generated from OBIS, the distribution of paralytic shellfish toxin producing species, amnesic shellfish toxin producers, and DST producers. But the key areas are indicated with the shellfish icons. This is where human poisonings have occurred or major impacts leading to long-term shellfish farm closures. Ciguatera, primarily confined to the Australian Great Barrier Reef region. Fish kills both in nature, but aquaculture industry as well are due to Corinia and Chatanella, Pseudo-Chatanella, and Heterosigma. The total collation of HADAD events in this region partitions like this: about half water discolorations, high phytoplankton abundance, and significant other parts, seafood toxins, mucus, mass mortalities, and so on. The toxin syndromes partitioning like this: paralytic shellfish toxins and secretaria, the most abundant, but low contributions from amnesic shellfish toxins, diuretic shellfish toxins, and Naltok shellfish toxins. And there's slight differences between Australia and New Zealand. Water discolorations more common in Australia, particularly Noctiluca. Foam events are more common in New Zealand. That particularly refers to Tasman-based slime, Gonialex hyalina type species. The seafood toxin syndromes, secretaria is the #1 problem in Australia, and it's never been reported from endemic New Zealand fish species, but it can still in the future impact New Zealand through the import of fish from neighboring regions. Now, toxic shellfish toxins never been reported in Australia, but noted in New Zealand in this particular massive incident that I already referred to. Looking at trends, and we have to be very careful because the data, as mentioned, are limited, but the best way to look at it is the number of geographic grids with one or more HADAD events. And over the period 1985 to 2018, there really is no trend visible. You also have to be aware that the intensity of monitoring has increased significantly, and we actually, when we correct HADAD events for increased monitoring effort, so the actual number of incidents is actually decreasing. This data set is preliminary, and over time, we can make those statements with more confidence. However, much more interest is looking at particular seafood industry areas. These are exclusively shellfish farms. This is Tasmania, south of the mainland of Australia. This is the period 1987 to 2018. We had, and this is expressed as the number of weeks that shellfish farms are closed. And we look at a number of shellfish farm areas. Here we have a period in the 1980s and 90s. We had problems with Jiminy catenatum. Ultimately, that area was closed for shellfish farm. And after a period of apparently no problems, we suddenly had a new problem appearing, Alexander catenella on the east coast of Tasmania, to a peak, and it also seemed to be slowly decreasing. These are all exclusively PST events, and there's a single DST incident recorded here with a shellfish recall. New South Wales, Sydney region, very large number of shellfish farms, very intensively monitored, but comparatively few problems, PST, AST, but also a few DST events. New Zealand, a very big shellfish farm industry, much larger numbers of biotoxin event weeks. Here, this is the early NSP events, lots of farm closures, also relating to uncertainties about the analytical methods to be used for testing. Once that was under control, a much lesser problem. Then a period with a big PST peak, and again, it's slowly decreasing. So again, there's no trend in those data over time. Particular events, Great Barrier Reef region, Secretaria, those data sets go back to 1965. Both expressed the number of outbreaks, but sometimes one outbreak leads to more than one illness, particularly when a particular big fish ends up on in a restaurant in, for example, Melbourne. But again, there is really no trend over time. The only thing that is becoming apparent here, that in the past, the phenomenon was confined to Queensland, but it's moving into northern New South Wales now. It's not yet clear whether it's due to a movement of the causative cambio-discus organism or a migration of cyclotoxic fish, or possibly both. The only real clear evidence of an expansion and an increase of a HAB phenomena is by Noctiluca scintillans, known from Australia, Sydney Harbour already in 1860, a major increase and expansion in the 1990s in the Sydney region. Ultimately, it moved to Tasmania, and it is now a very widespread phenomenon. It can be a problem for tourism, but surfers and tourists really enjoy the bioluminescent spectacles at nighttime. In conclusion, HADAD data are very complex, and we need to be very carefully how we interpret them against the key drivers of increasing aquaculture, increased scientific awareness and monitoring efforts, but also changes in regulatory approaches can affect the results. Different regions are dominated by different seafood toxins. PST is dominant, for example, in New Zealand. Ciguatera is a major issue in Australia, and neurotoxic shellfish toxins are so far only detected in New Zealand, but only once we had a major incident. Aquaculture fish kills can have far greater economic impacts than shellfish toxins. I mentioned that big incident with the tuna aquaculture industry in Australia, but we had Heterosigma and Pseudochatanel events also in New Zealand. Immersion problems, Noctiluca spreading, particularly in Australia, Ciguatera moving into New South Wales, and a major conclusion: there is no simple trend of increased distribution, frequency, or intensity by all HABs in this region, nor would that be to be expected. We need to look at every region on its own, and every species needs to be studied on its own. Thank you for your attention.